Hello guys, my name is Dylan. My YouTube channel is DRG Bros, and today we're going to be doing maps and functions 2. So topic 1 is going to be a review, and so we're going to ask the question, what is a map? So a map is a rule between two sets that specify an output for a given input. So for example, what we can do is we have this little chart here that allows us to draw circles. So I'm going to draw my circle. I'm going to draw 2 circles. So the first one is going to have the map set 1, 2, and 3, and so is the second one. And so we are going to connect these by drawing lines. So 1 is going to go to 2, and then 2 can go to 2, and then 2 can also go to 3. So this means we have our map. So what we can also write it as is a table, a T-chart essentially. So we have our input and our output. And so when you put 1 in, you get 2. And then when you put 2 in, you get 2 and 3. And when you put 3 in, you get an unidentified number. It's an unidentified number. So this is M1. So M1, or map 1, is from A to B. And so we can also write it as a chart. You can go. We can say 1, 2, and 3. And so this is 1, 2, 3. And so the dots go right here, and then 2 right here, and then nothing here. Because you get, when you put 1 in, you get 2, 2 and 3, and then nothing, or an unidentified. So what is a function then? So a function is a map with a restriction that every input has only one output. So we are going to draw something called map space. So here's my circle. So this is our map space. And so let's say there's a bunch of little maps here. So we have our maps and our map space. Now inside that map space is something that we can call the function space. So inside here is the function space where there's specific maps that are functions. And so here what we could determine is that all functions are maps because like the function is inside the map. But not all maps are functions. So that is for topic 1. And so let's move on to topic 2, which is additional map properties. So let's consider we have something like this. So we have our map again. So we have 1, we have 2. So here we have 1, 2, and 3. And here we have 1 and 2. And so here 2 goes to 1 and 2 goes to 2. And so this is an example of an onto map. The onto property is that every output has an input that achieves that value. So this is onto because they both, all the outputs are connected to an input. So let's take our map from earlier. 1, 2. And so this is 1, 2, 3. This is 1, 2, 3. And so this is our map from earlier. Now this is not onto because we are missing out on the 1. So let's look at another new map property. So this is called one-to-one. So we have our circle here. Here to here. 1. There. Okay. So this is 1, 2, 3, and 1, 2, 3. And then, but the lines go like such. So it's like there, and then there. So this map is called one-to-one because, and so this is the one-to-one because every defined input has only one output. So every input that has a line going somewhere, such as 1 and 3, has only one output, which is true. And every defined output, for example 1 and 3, has only one input, which is also true. So let's look at another example for here. So we have 2 circles. 1, 2. And so this one is 1, 2, 3, 1, 2, 3. Except 1 and 3 connect. In both terms. And then 2 goes to 3. Now, is this a one-to-one or not? The answer is no, because every defined output, so 3, has only one input, but it has both 1 and 2. So that means this is not a one-on-one. So we can move on to our final topic, topic 3. Other ways to view maps. So we're going to introduce a new symbol. And so this is, you draw it by drawing an R and then adding an extra line to it. And so this is the symbol for the real numbers. The real numbers is the set of all numbers on the number line, going from -4 to like 2, or like negative like 1 million to like 1/2, or even like pi, or like negative pi, and that type. So now consider the map space of all the maps, from the reals to the reals. So map 7, and so this is the real to the real. So we can draw a line like here to here, another line in the middle, and then the same height from here to here, and combine these two. And so this is 1. And so we can draw a curve. So it goes like, up and around as a curve. And so m sub 1 is equal to 4.1. And then m1 equals to 3.6. So, and then you're left with m1 equals 4.1 plus 3.6. So next we are going to test out all these. So we're going to draw a map. Yeah, 2 maps. And so one is 1, 2, 3, and one is on 2, 2, 3. So here is, okay, wait, I need to draw the box. 1, 3, 2. Okay. Is this a map? Yes, this is a map. Is this a function? Yes, because all inputs have only one output. Is this an onto? Yes. Is this a 1-to-1? Yes. And then there's even a new one that this is, and it's a permutation. And so they are all examples of this map. So now we are going to do one more example and show 2 tests for it. So we can draw a line right here. And so what this is gonna do is it's gonna allow us to determine whether it's a function or even a 1-to-1 due to this test. So what we can do is we're going to draw 2 of these. And so one curves like this. The other does this kind of zigzag like curve. And so there are 2 tests we can do. One is called the vertical line test. where if we take our ruler and then we put our ruler anywhere on here, if we get a vertical, if it only touches once, so like once it leaves the ruler, it only touches once on this curve, which is true, that means that this is a function. And so we can do it to this one down here too. So is this a function? It is not, because right here it connects 1, 2, 3 times. And then there's the other test, which is called the horizontal test. So the horizontal line test. So if we put our line vertically or horizontally, and if it touches twice, which it doesn't on this one, then it is a 1-to-1 also. Same with this one, meaning this one is also a 1-to-1. Thank you guys for watching. I hope you enjoyed, and I'll see you next time. Bye.